All right, howdy everyone. My name is Robert Caraway. I'm a PhD student here at Georgia Tech and a laser master here in the Invention Studio. We're going to be talking today about our Trotec laser cutters. This is not designed to replace the video that Jeff Park did a while back, one of the other laser masters. This is kind of to augment and supplement. And we're going to talk some more about some of the hardware specific stuff that we've learned from Trotec over the last little bit and try to give you all some updates on what we're doing and how we can run these machines better and keep them in better operation. But first things first, we're going to go sign into the laser over here. Today I'm going to be using Ivy, so I'm going to hit log in here and it'll have me logged in. So one of the things about these machines is that as they cut material, you can think of it as kind of burning or sublimating away material. Well, that creates debris in kind of a suspended and gaseous form, and that needs to be drawn out of the machine. So we have ventilation in the machine. So if you see this orange pipe coming up out of the back of the machine, going up to the ceiling. There's a blower on the roof that collects all of that and pulls it all out of the machine. If you want to come in here, inside the machine, this ventilation is open in the back in the form of these vents in the back. As we can see right now, if you look through here, you see that they're kind of clogged up a little bit. That's because over time, the vents will clog and just with all the debris and everything, in part because our ventilation is a little bit underpowered for the amount of wood and MDF that we cut here. So before we get too far into this, I'm going to take a shop vac and just vacuum out these vents just to make sure that I'm getting maximum flow through there. Nice and simple, just takes a minute. Can definitely help with your cuts. If you ever notice there's anything really specifically clogged in there, you can always get a brush or some compressed air or anything like that and get that out. There's also a vent down inside the bed that's a little bit harder to see in the video, but you can see it if you just come look down through it. If there's too much stuff at the bottom of the bed, that can also cause a clog. So I'll show you real quickly how we can take the bed off. So if we look here, we'll see that there's a button here and a button here. We can click those. And then you're going to pick it up, and you've got these two locating pins that you're going to come around. These locating pins are for the rotary, and when you learn how to use the rotary, you'll understand that a little bit better. And then you can just lift it up and pull it out. And so here we can see the vent that's underneath. We can also see all this debris and everything. If you ever notice that there's a decent amount of that in there, once again, just take the shop vac and just vacuum it out real quick. And then all you do is pick the bed back up, gently slide it in. You're going to line up the buttons and the locating pins. See our locating pins are lined up. Everything seems to sit well in place. You just click the buttons again to lock it back in. Make sure when you're taking this out that you make sure that the buttons are up so that they are not locked in and you don't damage them. So these two things we just did with cleaning out the bed and that lower vent as well as the back vents are a very quick and very easy way to help keep the lasers working well and keep the ventilation from getting clogged. Let's talk about ways to manage the exhaust when you're actually setting up your cut. Because these machines have interesting things here where they have these little knobs on them and you can actually open and close the different sections of the exhaust. So if I was to go across and close all of them, now there's no exhaust flowing through the machine. But that means that also if I just open one of them, there will now be more air flowing through this one section. Meaning that if I'm only cutting over here, there's no reason to have the ports open over there because I want as much airflow near my cut as possible. So what that also means we can do is so from here I now have open from here to here. That doesn't cover my entire sheet. But if I was to close this one and now open this middle one, I can now move my sheet to where now this one sheet fits entirely in one port. Same idea though, if I was cutting something that went from here to here, I would open those three and leave the fourth one closed. What's really important here is that you can get better productivity and production out of the machine by opening and closing the correct number of ports. But also you need to make sure that you're looking at the ports to make sure that they're open when you start your cut because the person before you might have closed some of them. All right, so we just finished talking about the ventilation. And so with ventilation, it pulls that smoke and debris up out of the machine to get it away from the cuts and away from the optics. So these machines have a fairly complicated optics chain, a lot of which is inside the wall of the machine. And then we've got two pieces of optics right here. The stuff inside the wall is harder to clean, but it's also less likely for smoke and debris to get to. Smoke and debris can get to these a lot, especially if you have your cut or engrave settings very poor. So we're going to talk about how to clean them, and then we're going to talk about how to get better cut and engrave settings. So a lot of you have heard me talk about test cuts, and I'm going to talk a little bit more about that and try to show you some examples of how they can be better. But first, let's talk about how we can fix it when things go wrong. So these optics are very sensitive and coated with special materials to make them work better than a lot of just standard mirrors and things like that. So they also have special cleaner. So here we have the special cleaner. You'll see it's this red dye. You do not use just any optics cleaner. This is what you use. If you ever can't find it, please let me or a studio assistant know, or one of the other masters, and we will get you the right cleaner. We use this. It's called a pocket rocket. It just blasts little blasts of air out of it. You don't want to use compressed air because compressed air can have sand and debris in the lines, and if you end up using that and there is sand and debris in the lines, you'll basically sandblast the optics, which, believe it or not, is not good for it. So, in order to clean these, we're going to take the optics out. So to take the lens out here, which is in this case in this gold bracket, you're going to take this screw here, you're going to screw it down, which is clockwise. If you're looking at it from this direction, you're going to screw it clockwise, and then you just slide the bracket out. And when we go to reinstall it, you'll just slide the bracket in and screw it back clockwise, or back counterclockwise. So when we pull the bracket out, you'll see that you can see that you have a metal bracket with a lens on it. Sometimes you'll look at the lens and you'll see little amounts of debris in the middle. You're going to try to just rinse those off with our optics cleaner here. Very often you won't be able to see anything, and if you can't see anything bad on the lens, that's a good thing, and it does not hurt it to clean it anyway. So to clean the lens, we're going to try to, the bracket has some walls on it, we're going to try to always set those down. We want to avoid touching the lens with our fingers. So you'll notice I'm always holding it on the side. It's got these walls. I'm going to set those down while I open up my cleaner. Open up the cleaner. Then I'm going to come over to a trash can here. I'm wearing gloves for this. It's up to you whether or not you choose to. I sometimes don't, but it's, you know, the safest thing to do is to wear some gloves. This stuff isn't very dangerous. It's kind of like IPA, just a little bit of extra stuff in it. You're going to take, and you're just going to kind of rinse off your lens on both sides. If you ever have something like that looks like it's kind of built up on there, you can feel free to kind of let it sit there and set it down for a couple of minutes and let it kind of sit on there. But at the end of the day, the main thing you do is you rinse off. Rinse off. Now that it's like that, we're going to take, if we just let it dry naturally, because some things can weird happen, but what we want to use our pocket rocket to kind of dry it off and help move anything off of the lens that the coating solution might have loosened up. These lenses do not have an airtight seal around them, so as you clean one side, you're actually going to move a little bit of liquid back to the other. So you have to dry both sides of them, and you're going to have to kind of go back and forth a few times. You end up cleaning multiple machines, or even if you have one of these that's particularly dirty, you'll end up getting a little bit of a forearm workout too. So if at any point you see something on the lens that does not come off just by rinsing it off and then using the pocket rocket to dry off the bracket, that's when you need to make sure to let a laser master and the studio assistants know, because we have some extra cleaning things we can do in that event. So just go ahead and mark the machine down and let us know, and we can probably fix that. If you see something like that and you don't mark the machine down, really bad things can happen. We can end up breaking the optics, or worse, we can cause damage inside the machine. It's very important to clean these often and clean them well, because damage inside the machine and breaking an optics takes a lot more money and a lot longer to fix, whereas if we just regularly clean these, they can last for years. So now that we've cleaned and dried that, I would generally set it aside. Just set it right here, once again, setting it there with the walls down so the glass is not touching anything. Now I'm going to remove the mirror. The mirror, you can see, it has these two thumb screws and these two normal screws. The normal screws you should never touch. It should require no tools to clean this beyond just your optics solution and your pocket rocket. So I'm going to take my thumb screws here, and I'll loosen both of them up a little bit. This one here at the top is a little bit annoying to get to. I understand that, and that's just kind of the way it is for right now. And so now I'm going to hold the mirror with my off hand as I actually get the screws out, because I don't want the mirror to fall. because scratching the mirror is about as bad as the debris that might be on it, because that once again would damage our optics channel. Very gently pull it off. Try not to scratch it or anything. Once again, same thing. I'll hold it from the edges and always try not to actually touch the mirror with anything like my hands or anything like that. All we want to touch the mirror is our cleaning solution and some clean air. So same thing as we did with our lens. We're going to take our mirror over to our trash can. We're going to put some solution on there. Roll around a little bit. Rinse it off. Do it again. Now we've got that. We're going to take our rocket and dry it off. Now I have a clean, dry mirror. I don't know if you can see yourself in it, but if I look at it, I can definitely see myself. It's got a little bit of a gold color, so you can look at yourself in beautiful magnificence. So now that we've got these dried off, generally I like to put the mirror on first and then the lens, but the order's not really a big deal. So I'm going to take, I'm going to hold my mirror, get one of my set screws, slide it in there gently. Try not, once again, we're working very hard not to scratch the mirror. We don't want to touch the glass to anything on it. So we're going to set it in gently. Take our screw, find the hole, get it started. Now that that one's started, I can let go of it, take the other one, get it started, and then just get them tightened down. We are not trying to take pliers to these. These do not need to be tool tight. Just finger tight is good. You just want to have them tight enough that if you take and you shake the mirror, it doesn't move. That's what we're looking for. Same thing with the lens. Once again, we're going to grab it by the edges, slide it in, and screw our housing up. Finger tight, once again, do not put these on super tight. Don't care how strong you are, it doesn't need it. Once again, I just want to shake the bracket a little bit. Does it move? No, we're good. Now, we've now cleaned our lens and our mirror. Now we're going to actually talk about some new updates in terms of running the machine. So the main thing here is test cuts. So when we open Inkscape on these computers, you'll notice that there's two boxes, a black box and a red box. Those represent your test cuts. The idea is that you're just going to put those somewhere that's a scrap area on your material and run a test engrave and a test cut. Now, if you're only engraving or only cutting, you might only need one. A lot of people don't seem to understand why we do this. So we're doing these so that we can get our material settings right before we start cutting. Because if I run an engrave and I do an entire sheet of material and then I decide I want it to be deeper, I've now doubled the runtime, whereas if I just did it on a small square, I'm only going to lose a couple minutes. Same thing with the cuts, except worse, because with the cuts, with an engrave, you can kind of just do another layer and it's not as big of a deal relative to the smoke and debris and everything that's produced. With cuts, after you've cut once into the material, the kind of melted and burned material that's now in that path is not the same material you started with, and it doesn't cut in the same way. So you actually produce even more debris and more smoke, which is really harmful to the optics. So we've had a lot of people coming in over the last few years that have been cutting MDF in, say 4, 5, 6, 7, 8 and up passes because they were taught that using 100 power on the laser wasn't good. So the big update here is you want to do, using 100 power on the laser is fine and using slow speed is fine. As long, you don't want to see flames and things like that, but you want to cut your material in one pass. It's not cutting in one pass and you've already really slowed down the speed and the power and you've really raised the power. That's when you need to let us know, because that means something's wrong with the machine. And that's also when you definitely need to double check your optics. So let's talk about how we can do test cuts to get better cuts and better performance out of our machine. So we're going to turn our machine on and let it go ahead and be initializing while we start doing stuff on the computer. So we're going to open Inkscape, and we're going to open our job control software. So the job control kind of open in the background while we start running Inkscape. So these are those two test squares I talked about. These are about ½ inch in size each, and they're a fine way to start. What I'm probably going to change these to is I'm going to recommend that we make our engraved square a little bit smaller, because we don't really need a full ½ inch by ½ inch, and so this will save us some time and that sort of thing. Now, our cuts, actually, we want to do a little bit bigger because we want them to be more representative of our final cut, so I'm increasing that from ½ inch to 3/4 inch. Well, now, the other nice thing I can do is I can actually put these inside of each other. So that now I just have one test cut and one test engrave that are inside each other, one file. I can send those both to job control at the same time, and then we can just move them around on our part as we need to do more and different test cuts. So I'm going to do Control P, print that just like we always do. I'm planning to cut in this section. I don't know if you can tell, but I've kind of got an area that I've already cut out of this. So over here's kind of my scrap area. So I'm going to do my test cuts over in the scrap. So if I'm planning to be cutting over in this area, I'm going to look at my ventilation and I'm going to close these and I'm going to open the ones near where I'm working. Now in this case, I actually want to close that because right here I'm going to be working right here. So this ventilation port is good. But in reality, what I can also do is shift it to where now where I'm going to be cutting is in the middle of the port open area, which is even better. So we've now got our material where we want it. We're now going to bring the head over and we're going to focus. So this machine specifically has two different ways you can focus. We have the method with the little key. You set the key on the shelf and you raise up the table until the key moves or falls from contact with the material. And that's good to go. I believe, once again, Jeff went over that in his video. The new thing here is that this machine actually has, you can tap the up and down on the Z at the same time, where it says AF here. And the machine actually has a sonar in the back that can actually find your material and autofocus for you. Now, what you'll notice is that if you then, after it's finished autofocusing, once again it beeps to tell you it's ready, you can take the key, set it on here. If you look very closely, you will notice there is just, I mean, the tiniest gap there. So they are ever so slightly different on the magnitude of, hundredths of an inch. Now, in this case, on this material, I'm not planning to do an engrave, but if I was, I would just turn on my engrave settings, run some settings, see if I liked them, and then work it down. The beautiful thing here with this new test engrave system, cut system, is that once I get one of them right, I can just turn it off and continue to test the other one without wasting time with one or the other. And then when I'm ready to cut my actual part, I just bring in my part job, turn this back on, and it will have the same settings I was just doing that I just tested and know for a fact work. So in this case, I don't need an engrave, but so I'm just going to turn it off. I'm just trying to cut. So let's say I knew nothing about my material. What you want to do is you want to look at our wall here, and you want to figure out which of these settings, which of these material types was closest to what you were doing, and you can use that as a good starting point. These will be updated regularly. We've actually just found some new updates to these that we're planning to put on the wall soon. Use these as guidelines. At no point should you just walk up, put your material in, put those settings on, and do a big cut. These are places to start your test cuts from. These are not always going to be right for your material because each manufacturer will make material differently, and a lot of times with things like MDF, you have a lot of non-homogeneity. So I'm going to start with what I think might be a good setting here, and I'm going to use a Z offset. Generally speaking, you want a Z offset between 0.04 positive for engraves, negative 0.04 for cuts. 0 is going to be generally good for everything, but for sometimes adding a negative offset for a cut or a positive offset for an engrave can help get you some better properties. Once again, these are things that you can test with your tests and really dial into exactly what you need in terms of cut quality and kerf and things like that. So I'm going to start with a negative 0.04. I'm going to do 100 and a 1.5. Update my time, see that it's 2 seconds, that makes sense. Okay, so we're about to start our cut and see what we get out of this. So I'm gonna hit start on the machine, hit OK. Now it's gonna shift slightly because this machine has a flex laser in it. We can talk more about that later. So what we see here is you see all those streaks and everything like that in the acrylic. That tells me that was not a good cut and did not go all the way through because of the way that the smoke and everything moved around. If I was to open the machine and try to pop it out, that piece would not come out. It did not cut all the way through. When you're cutting acrylic, especially clear acrylic, it should look like a ghost is cutting it. With MDF, it's gonna look a little bit more kind of smoky and a little bit things like that just because of the nature of the MDF and everything that's inside of it. That was not a good enough cut, so I'm gonna move my laser down. I'm going to reset my part here, move it down to the new spot on where I just moved the laser to, hit job reset, and I'm gonna come in here. I've already got my power at 100, so I'm gonna lower my speed. I happen to feel like, I believe that 0.8 is gonna do a better job. But even if I am going too slow, I can either stop the job in the middle, or most likely I can just speed it back up if I need to on the next one. So I'm about to hit OK and run the next one. And here we go. Okay, so we saw a little bit of smoke there and a little bit of debris. It wasn't bad. I'm not sure though, so that one looked pretty good. I could open it up now and check on this one, but just because I already know what we're doing here because I ran these before we started the video, I'm gonna run one more. I'm gonna move the laser down again. I'm going to move my job again to a new spot. Job reset. I'm gonna drop this to 0.6 and I'm gonna hit OK. And I'm gonna hit start. And we're gonna run a third one here. What you saw there was, it looked like a ghost cut that. There was very little smoke, very little debris. It looked like it cut clean through. Now I'm going to open the lid and let's see what we got. So if I pick up my material, we see that the 0.6 one fell right out. This one that we ran at 1.5 was absolutely not cut through barely at all. And this one at 0.8, I can kind of feel that it's almost cut through on the back. It's cut through on like this top line here and the bottom line. The edges are kind of perforated to where if I needed to break this out, I could, but it's not actually good. So if I'd run this at like 0.75, it might almost come out. What you really want out of your test cuts is you really want them to just fall out like this. And so now what we see is I've used like 3 inches of material by like 1 inch of scrap. And now I can cut my entire thing with these good settings from this 100.6 and feel confident that I can cut my entire piece and it be good. But let's just review real quick the things we learned today. So we talked about the ventilation. We talked about how important it is to make sure that you open and close the correct vents here at the back. Also moving this laser arm, you can do that when it's off. If it has any resistance to it, don't do it. But if it slides gently, you can move it around as you need to. We talked about how to remove the mirror and the lens to clean those. And I'd recommend you do that before and after any big cut you're doing, or especially if you're a PI and just on shift one day and don't need something else that you're looking to do, that would be a great thing to do while you're on shift. Then we also talked about test cuts and how important those are and how to make sure that we can then get good performance out of our cuts before we actually start doing large cuts. We just use a little bit of scrap material and that saves us a lot of time and effort. So thank you all so much for watching. I hope you got some value out of this. If you have any questions, please let me know. Now it's time to sign out and move on with our day.